This is my header section. Everything included is the usual ones except stdbool.h, which I had to include because of the Boolean use in the while loop. And then we defined buffer size and file size. We defined these because you can just change the number here once, and it changes it for every single time you use the variable buffer size, or the constant buffer size, or the constant file size, and you have to change it every single time. So we created a Boolean named working, and we set it to false from the start because the program is not yet inside a JPEG. Then the program is going to read all the information in the file pointer fp, and we already put all the information in argv1 inside fp, and it's going to read that until it gets to the end. Then we have an if statement that says if it is in the first JPEG, do this. We know that this will be the start of a JPEG because that is always the first hexadecimal in a JPEG. That's always the second one. That's always the third one. But the fourth one can be a multiple of ones. So we had to bitwise and 0xf0 and 0xe0. And using that, we can find out what the fourth hexadecimal will be in the JPEG. And actually, it took me a very long time because I kept using 2 ampersands instead of 1 ampersand using the bitwise function because I thought it was just like an and instead of a bitwise and. So once it's inside the first JPEG, we're going to set working to true because we know that it's in a JPEG. And here we go, if working is false. So if it didn't get to this part, it's going to printf, no JPEGs are in this file, and it's going to return 1. We have to have this because if a file just has zeros all the way through, it's going to get in there, but the user is going to see no output and he's going to be very confused. But since we have this there, 1 is going to be returned and it's going to have no JPEGs are in this file printed, so the user knows exactly what's happening. So here I use the sprintf function that was taught in the CS50 Harvard video, and we use this we put %03d.jpg, so it's going to do the 03d, that's going to be a random number. It's going to say 000, and the next one's going to be 001, and it's going to be 002, all the way up to 049, and it's always going to have the decimal JPG, so we know it's a JPEG. It took me a while to figure this out because I kept putting, in retrospect, this doesn't make any sense, but I kept putting 03% D, and I would get like 030 instead of 000. And the number that it's going to use is counter. So the first time it goes through, it counters 0 because we defined that earlier. We have to do this because if it's all under one JPEG or if it's all under one variable using the sprintf function, all of the JPEGs are going to be in one thing, and we're going to have what we started with originally. So then we open Harvard Photo. Harvard Photo is the file printer, and we use file name because that was defined in sprintf, and we do that with the intention to append it. And every time it finishes this loop, counter is going to raise by 1. So the first time the sprintf function is going to do 000, and it's going to go through it. Counter is going to increase by 1, and it's going to be 001.jpg. So they're not all in the same name. So now we have an if statement, and it says if counter is greater than 0, it's going to basically just print to the output photos. The FP is Harvard Photo again. We use if counter is greater than 0. Basically, this just tells us that it went through the loop right above this, because at the top we had counter plus plus semicolon. At the bottom of the last loop we had counter plus plus semicolon. So if counter is not greater than 0, we know it just didn't go through there, so it's not going to print it. If we didn't have that, it would crash because it would try to print stuff that just is not there. And if it was never in a JPEG in the first place and working is true, it's going to print no JPEGs are in this file because it never found the first 4 hexadecimals of a JPEG. So my program tells you that there's no JPEGs in the given file. And then it's going to turn 1 to show an error. And at the end, we're going to close the output file pointer, and we're going to close the memory card file pointer just so they don't leak any information at the end, and so our program is much more secure. And then we're going to return 0 at the end, so the program just states that everything went well correctly and no 1s are returned, only a 0. And yeah.